Chapter 13 starts on page 281. We're going to be interpreting doctor's orders for dosages and day supply. So we have covered this information before in the supplemental math lecture, but this chapter does go just a little bit more in detail on some of these concepts. So as a reminder, sometimes physicians will leave out how many doses of medication needs to be given in total. And in that case, if they give us the day supply and they leave off the quantity, we're going to have to calculate the quantity. Same as when they give us the quantity and leave out the day supply, we will have to solve for the day supply. Now remember, with liquid medications, we would not want to leave the sig as a weight for the patient. We need to leave that as a dose volume, so it is easy for them to either draw that up into a syringe or measure that out with a medication cup, whatever it may be. When you get a prescription that is handwritten and you absolutely, cannot interpret what the prescription is saying due to maybe poor handwriting or it just doesn't make sense. In that case, once you ask the pharmacist first, that may, delegate a call from the pharmacist to the doctor's office to confirm what exactly the order is saying. Usually that is happening less and less now because most of the orders that come through are going to be electronic rather than handwritten. Just as a review, a dose is the amount of medication that is taken at one time, whereas the dosage is going to be how much medication the patient needs for the entire duration of the prescription. So the dosage is going to be the same as the quantity that needs to be dispensed, for the entire prescription. So we're going to take a look at some examples here in the book. Okay, I'm looking at number 1 on the pretest, still on page 281. So a physician prescribes amoxicillin suspension, 250 milligrams per 5 ml, 150 milliliters, and we have a sig for 1 teaspoon 3 times a day until the entire amount has been taken. Include a dose spoon. How many days will the medication last? Okay, so let's go over a few things here in this problem that we need to make sure that we are clear on. So the amoxicillin suspension itself is 250 milligrams per 5 ml. Now this is what we designate as the strength of the medication or the concentration. And it says that they are going to be given a total of 150 milliliters. So 150 milliliters here, that is the quantity. The quantity that is going to be dispensed, or if you wanted to, we could consider that to be the dosage. Means the same thing. How much are they getting in total? So we have the strength, we have the total quantity that they're being given. We have the directions here. So they're taking 1 teaspoon 3 times a day. So remember, a dose is how much they're getting at one time. So this 1 teaspoon, that would be their dose. They're taking it 3 times a day. How many days will the medication last? So we are solving for day supply. Day supply is how long a prescription will last. And if you remember the day supply equation, which I do have this at the end of these math slides, which you can refer to, but I'm just going to write it down here as well. Day supply is quantity dispensed divided by quantity taken per day. Don't forget the per day is very important here. So remember, we have the quantity that's being dispensed. We have this first numerator here. We need to figure out how much are they taking per day. So they're taking 1 teaspoon 3 times a day. So in one day, they're taking 3 teaspoons. But we see that our quantity dispensed is in milliliters. It is not in teaspoons. So immediately we need to realize that we need to convert this teaspoon into milliliters. So 1 teaspoon is 5 milliliters. So they're taking 1 teaspoon 3 times a day. They're taking 3 teaspoons in a day. So 3 teaspoons would have to be 15 mils. We're taking 5 times 3. So 3 teaspoons is 15 mil per day. Now, if you needed to use ratio and proportion for this step, we could have done that. But I want you to get in the habit of, visually seeing, well, if 1 teaspoon's 5 mils and they're doing that 3 times a day, 5 times 3 is 15. So we now have the quantity dispensed, and we also have the quantity that they're taking per day. So we can plug this into my day supply equation. So they are dispensing 115 mils. They're taking 15 mils a day. 150 divided by 15 would give us 10 days. So the prescription should last the patient a total of 10 days. So once again, I have the description of day supply here in the slides. So please note, day supply is how long a prescription will last, how many days it will last. Now, this information is important because insurance companies require us to submit a day supply with each prescription that we fill. It really helps out with things like refills, knowing when the next refill is due, knowing if we need to contact the prescriber for a new prescription or for them to authorize refills on a prescription. And also, if somebody comes in trying to refill a prescription too soon, that is a red flag that maybe they're taking their medication incorrectly and they are going to need some additional counseling, or in some cases, a med change or med order change may be sufficient for that case. So I also have this formula here. You really have to make sure that you know this formula and you understand this, and that you are able to calculate the day supply for a prescription. So I also put on here a little note at the bottom. This formula does not work for orders that change directions throughout the duration of the prescription. Okay, so if your SIG in the middle of the SIG has a direction change, you can't just simply plug numbers into this formula. So I'm going to go through a problem like that here from the book. Okay, I am on page 315. I'm in the post-test on number 5. So here, a physician writes a prescription for Decadron, dexamethasone taper, using 0.5 milligram dexamethasone tablets. The SIG is to take 1 by mouth 4 times a day for 2 days, 1 3 times a day for 2 days, 1 twice a day for 2 days, and 1 daily for 4 days. Now, I just wanted to look at this example to show you that this is a problem in which we could not just plug numbers in to an equation to find the day supply. However, this SIG gives us the day supply. We just have to figure it out. So we know that they're going to do, excuse me, the first set of directions for 2 days. So we know that we have 2 days here. Then they're going to do 1 3 times a day for 2 more days, 1 twice a day for 2 more days, and then 1 daily for 4 days. So remember, day supply here, we just need to figure out the total number of days that this prescription will last. So if we have 2 plus 2 is 4, plus 2 is 6, plus 4 more, that would be a total of 10 days. So in some of these calculations, you'll just have to figure out the day supply in that regard. Okay, so this question here says, how many tablets are needed to fill this prescription? So here we're looking for the total quantity or the dosage. So how much are they getting in total here? So we have 0.5 milligram tablets. They're taking one tablet 4 times a day for 2 days. So we need to write this out here. They're taking one 4 times a day for 2 days. So if we just look at this section here, 1 times 4 is 4 times 2 would be 8 tabs here. And then we'll break it down into each section. So then they're going to take one 3 times a day for 2 days. That would give us 6 tablets here. And then they're going to take one twice a day for 2 days. So one twice a day for 2 days. That gives us 4 tabs there. And then one daily, so just one time a day for 4 days. That would give us just 4 tablets there as well. So now all we have to do is find our total quantity. So 8 plus 6 here, we have 14. Plus 4 would be 18. Plus 4 more would be a total of 22 tablets. So this one, you kind of just have to break it down by section to figure out the tablets needed for each part, and then add those together for the total quantity. Okay, so the second question here says, how many milligrams of dexamethasone would the patient receive on each day? So it says on days 1 and 2, and remember we're looking for milligrams. So on days 1 and 2 here, they're taking 1 4 times a day. Okay, so it's saying how much would they receive in the day? So if each tablet is 0.5 milligrams, and they're taking that 4 times a day, then we can just take 0.5 times 4. So 0.5 times 4 would give us 2 milligrams. So on the first day 1 and day 2, they're taking 2 milligrams each day. And then we would just do the same thing here for the rest of these. So on days 3 and 4 here, they're taking 1.5 milligram tablet, because that is our dose, and they're taking that 3 times a day. So 0.5 times 3 would be 1.5 milligrams here. And then, so we have day 1, 2, 3, 4, so days 5 and 6, they're taking 1.5 milligram tablet 2 times a day. So total, they're taking 1 milligram per day. And then on days 7 to 10, so these last 4 days here, they're just taking 1 every day. So 0.5 milligrams at a time. They're just taking that 1 time a day. So they're getting 0.5 milligrams per day. Now I'll leave you to indicate the label directions here. You should by now be comfortable with interpreting the SIG. You just have to write out the SIG without abbreviations. Remember, we always start with a verb. So in this case, we have tablets, so you would start with take. So take 1 tablet by mouth 4 times a day for 2 days, and then going on here, filling out the rest of that SIG. Okay, another concept covered in this chapter is to determine how many doses we have in a container. Now, this is important when we're dealing with liquid medications, or it could be tablets as well, to determine how many containers we need to actually dispense to the patient for them to have enough medication for them to last for the entire duration that they need. So here I have this little equation here. The number of doses in the container, well, you're just going to take the total amount of medication that's in that container and divide it by the dose size. So let's take a look at an example from the book. So I am back onto the pretest now. I'm on page 284, looking at number 7. So this is going to kind of combine the concepts that we've considered so far. And when we're looking at how many doses are available in this prescription, that is the concept that we're going to cover that I just talked about here. So we got to solve these two questions before we can get there. So a physician prescribes ibuprofen liquid 10 milligrams per kilogram. Now that should look familiar from last week. Remember, anytime we see a dose that is milligrams per kilogram, we're going to have to use that kilogram rule, okay? So like I've mentioned in the past, this math just keeps building upon itself. So you got to be comfortable with chapter 12 before we can move on to chapter 13. So they're going to be getting this medication 4 times a day as needed for pain, and the child weighs 66 pounds. The available medication is 100 milligrams per 5. The volume of medication to be dispensed is 8 ounces. Okay, so once again, we have our strength here. That is our strength. They're getting 8 ounces, so that's going to be our quantity or our dosage. Now it says how many milliliters are needed per dose. Well, all we know about our dose is that they need to be given 10 milligrams for each kilogram that they weigh. And what we know about the patient's weight is that they weigh 66 pounds. So the first thing I need to do is convert the 66 pounds into kilograms. So remember, 1 kilogram equals 2.2 pounds. So if we take this 66 pounds and we divide it by 2.2, we get 30 kilograms. So 66 pounds would equal 30 kilograms. If you needed to do ratio and proportion, you could have set that up just as well. That works out the same way here. So we know that they are 30 kilograms, and we know that the prescription is for 10 milligrams per kilogram. So if you look back to your kilogram rule, we always take the dose given in milligrams per kilogram times their weight in kilograms. So 10 milligrams per kilogram times 30 kilograms. Well, 10 times 30 gives us 300. Our kilograms cancel out, and we're left with milligrams. So they need 300 milligrams per dose. But the question is asking how many milliliters do they need per dose? So in this case, we're going to need to find our dose volume. And remember, when you're looking for dose volume, you take the strength in milligrams and set that equal to the strength of your medication. So we know that the medication strength, there is 100 milligrams in every 5 mils of solution. And we also know that our patient needs 300 milligrams. So we're going to solve for X there. So once you solve for X, so cross multiply here, 300 times 5, 300 times 5, that gives us 1,500. And then we're going to take that divided by 100. So X equals 15 milliliters, okay? So that is our dose volume. That's milliliters per dose. So we had to do a couple steps before we could even get there. So make sure that you're reading your question very carefully and that you're able to interpret all of the information the problem is giving you. So now this next question says, how many milliliters of medication would be needed for 1 day? Well, if we look at the order, they are getting this dose 4 times a day as needed. So if this is our dose volume, they're taking 15 mils per dose times 4 times per day. Well, 15 times 4, that would give us 60 milliliters per day. Now it says how many doses are available in this prescription. Okay, now remember our dose was 15 mils. So our dose is 15 mils. That's how much they're getting at one time. And we want to find out how many doses are in the prescription. So how many doses are in the bottle? So that's the slide that I just talked about. Now, it says the volume of medication to be dispensed is 8 ounces. Well, this is in ounces, our dose is in mils. So we're going to need to first convert this 8 ounces into milliliters. So by now you should know that 1 ounce is 30 milliliters. And from there, we can figure out how many milliliters are in 8 ounces. Well, 8 times 30, if you plug that in your calculator, is 240. So 8 ounces is 240 milliliters. So that is how much we're giving them in total. So now to find out how many doses are in that container, we're just going to take the size of the container, 240 mils, and divide that by our dose, which is 15 mils per dose. And that's going to tell us how many doses we can actually draw out of that container. So 240 divided by 15 mils per dose gives us 16 doses in that container. So we can draw up 16 doses from the 8 mils. Now it says, indicate the label directions using household utensils. So here we know that, remember our dose was 15 mils. So they need 15 mils 4 times a day as needed. Well, you should be able to look at your conversion chart and see that 15 mils is equal to 1 tablespoon. So if they wanted the SIG in household, we would say take 1 tablespoon by mouth 4 times a day as needed for pain. Now, this is not on here, but I want us to now solve for the day's supply. So what day supply could we submit to insurance here? So remember, we take the quantity dispensed. We said that they're dispensing 8 ounces, which is equal to 240 mils. So they're taking 240 mils. We're giving them 240 mils. And we divide that by how much they're taking in per day. Well, we solved that here. How many mils are they taking in one day? We said in one day they can take up to 60 mils per day. So 240 divided by 60 gives us 4 days. So this is an as needed order, but if they do decide to take this 4 times a day, this bottle will only last them a total of 4 days. Okay, I'm going to take a look at one more example here. I am on the pretest number 6. I'm on page 283. So it says we have in stock Toprol XL 25 milligram scored tablets. So scored tablets are the ones that have that little line in the center. So these can actually be broken in half. It says, unlike most extended release tablets, Toprol XL can be split as long as the half tablet is not crushed or chewed. Okay, so here's an example of a written order. Now this one actually isn't too bad, but when you're going through your assignment, you're going to see some written orders that, are going to be a little bit harder to interpret. I want you to do your best on those. And if you have any questions, if you can't make out what they are saying, feel free to ask me to, confirm what the order is actually saying there. So here we have Toprol XL 25 milligrams, and we know that because they tell us here in the problem. And it says 1/2 by mouth every day. So I'm just going to write the directions here so we can have that clear. So take 1/2 tablet by mouth every day. So we got our SIG now. It says how many tablets are needed to fill the prescription for a month's supply. So also in your book, it tells you that a month, we always assume is 30 days unless otherwise specified. So in this example, our day supply needs to be 30 days. It needs to last the patient 30 days. And it's saying how many tablets are needed to fill the prescription. So here we're looking for the dosage or the total quantity that we need. So if they're taking half a tablet every day for 30 days, they're taking 1/2 tablet once a day for 30 days. Well, 1/2 times 30 would be 15 tablets that we would need to give them a total of 15 tablets. Now this next question says, what metric weight of the drug will they receive with each dose? So metric weight, we need to know that we're looking for milligrams here. That is the weight that we use in the metric system. So each tablet is 25 milligrams, but with each dose, remember, they're just taking half a tablet. So we need to find out what 1/2 of 25 milligrams is. So remember, anytime you see of, that indicates that we need to multiply. So 1/2 times 25. So 25 times 1/2 gives us 12.5 milligrams per dose. Okay, one last example from the pretest. On page 286, I'm looking at number 12. A physician prescribes atenolol 75 milligrams by mouth every morning, 25 milligrams by mouth at bedtime. The available stock medication is 50 milligram tablets. How many tablets are needed for a 30-day supply? Now, they're taking 75 milligrams in the morning. So first we need to figure out how many tablets are they taking in the morning. Well, we know that one tablet is 50 milligrams. So if one tablet is 50 milligrams, we can set that equal to our morning dose, which is 75 milligrams, and put that, solve for X here. So we're taking 75 essentially divided by 50, and that gives us 1.5 tablets. So in the morning, they're taking 1 1/2 tablet. And then at bedtime, they're taking 25 milligrams. So, you may be able to see that 25 is just half of 50, so they would need half a tablet. But if you need to set that up, go ahead and do that. So once again, we know that one tab is 50 milligrams, and we're solving for 25. So 25 divided by 50, that would give us 1/2 a tablet at bedtime. So we know that they're taking 1 1/2 in the morning, 1/2 at bedtime. How many tablets are they taking for 30 days? So first, let's figure out how many tablets they take in just one day. Well, if they take 1 1/2 in the morning, 1/2 at bedtime, 1 1/2 plus 1/2 gives us 2 per day. So 2 tabs per day times 30 days, because they are taking it for 30 days. 2 tablets a day times 30 days, that gives us 60 tablets total. We'll need to dispense a total of 60 tablets. Now, it says write the directions as they should appear on the prescription label. We would not leave the instructions in milligrams. We would not expect the patient to have to figure out how many tablets to take at one time. So we would need to give these tablet instructions. So take 1 1/2 tablets by mouth every morning and 1/2 tablet by mouth at bedtime. So once again, make sure you are as clear as possible for your patient on those label directions.